Hello, everyone. My name is Mustafa. I'm the co-founder of LazyLedger, a project which I've been working on for the past year. Before that, I was a scalability researcher, researching layer one scalability for blockchains, which I did a PhD on at University College London. In the first half of this talk, I'm going to talk about what LazyLedger is, first of all, and then I'm going to talk about why I believe it's important for Cosmos and why I think it's solving what I think is the most important problem that Cosmos is going to face in its near to medium term future. So at LazyLedger, we strongly believe in the kind of Cosmos vision, where instead of having a single chain or a single blockchain where everyone runs their application on, the Cosmos vision is where there's an internet of blockchains, or there's multiple blockchains that can communicate with each other, and they all have their own kind of sovereign zone and have control over how they execute applications, or the general vision where you have one application per blockchain. But the biggest problem with this vision that will be faced is that there's a huge kind of developer overhead and bottleneck in terms of actually creating a new blockchain or a new Cosmos zone for your application. Because as it currently stands at the moment, if you want to create a new Cosmos zone or Tendermint chain, you effectively have to create your own consensus network using proof of stake. And in many cases, that's actually very desirable. It can be very desirable to have sovereign consensus for different applications. But in many cases, for developers that just want to release a simple application, that's a lot of overhead just to release an application. And this also results in a fragmented security model where different zones have different levels of security, because effectively anyone can create their own zone that can be very insecure, for example, and only has one or two validators. And in those cases where the developer just wants to quickly release an application, while at the same time having the same benefits of having the control and flexibility of a Cosmos zone, it can be useful to, instead of requiring them to create a new consensus network, allow them to instead plug in a general purpose consensus network or layer one. And that's effectively what LazyLedger provides. So LazyLedger is basically the result of the question that you might ask yourself, which is if you take a layer one blockchain and strip back a layer one blockchain to its core components, what do you get? And you effectively get LazyLedger. So we've taken back a blockchain to its core components and made it very, very scalable. And that's effectively what LazyLedger is, and that's why it's called LazyLedger, because it does the bare minimal that a blockchain is supposed to do to allow people to build any kind of application they want on top of it. And the two core things which a blockchain should do is consensus and data availability. And I'll explain why in a moment. So in current blockchain designs, such as Bitcoin, Ethereum, and pretty much every blockchain, all operate under the same standard paradigm, which is that if you're a consensus node in that blockchain, in order to validate a block and to check that block is actually correct, you effectively have to do two things. First of all, you have to actually check that the block has consensus using a protocol such as proof of stake or proof of work. And then secondly, you have to actually execute the transactions in that block to make sure they're valid. And so you effectively have to know what the rules of those transactions are. The obvious problem with this is that in order to validate a block, you have to basically process every transaction in that block. And that basically means you have to do some amount of work for every transaction in that block. And as everyone knows, that doesn't scale because you can't have a situation where everyone executes every transaction. And that in some way is what Cosmos kind of solves in some way by allowing different applications to have their own blockchain. But as I mentioned, the problem with that is that you get this fragmented security where each blockchain can be insecure or secure. And so in the LazyLedger design, instead of having consensus nodes or validators or even full nodes execute any transaction on the layer 1 chain, nodes simply have to check that the transactions have been published. So they don't actually have to care about what the transactions are or if they're correct or not. They just have to care about whether the data behind that transaction has actually been published. Because you don't want to end up in a situation where a block producer publishes a block header but does not actually publish the transactions that block header commits to. In that situation, then people cannot compute the state of the blockchain, and they won't know what their balances are and what the account states are for that chain. And so that's why we say that if you strip back a layer 1 to its core components, the two core things you need to have a basic functioning blockchain that does consensus is to have consensus and to also have what we call data availability, which is to make sure that the block headers that the consensus agrees on is the data behind those block headers have actually been made available so that people can actually compute the state of the applications that are on the chain. Because without that, then that effectively results in a coin burn attack where people can, or block producers can create blocks and not release the data behind that block. And so no one knows what the state of the chain is anymore. And that's effectively equivalent to burning everyone's accounts and coins. So you can basically imagine LazyLedger as a very basic blockchain where anyone can just post arbitrary data onto it, and the validators of that chain don't care what that data is. And that's at its core what it is. Now we make this very scalable by using a primitive called data availability proofs. And data availability proofs effectively allow you to check that the data behind the block is available without downloading the entire block. And I'm not going to go too much into the details of how it works. You can check out this paper if you want to get into the core details. But effectively, the core idea is that by committing to the block in a certain way, using something called the erasure code, you can split the blocks up into chunks in such a way that you can construct this random sampling protocol so that by only downloading less than 1% of the block, you can have a very high probability guarantee that the entire block has been actually published to the network. And so that effectively allows you to validate the entire chain without actually executing any transaction and without actually downloading the entire chain. And this is basically very similar to what blockchains like Coda try to achieve, that use zero-knowledge proofs to avoid the need for everyone to download all the data or execute every transaction. So the obvious question you might ask there is, how do you build apps on a blockchain that doesn't validate transactions? Because what happens if someone just posts invalid transactions? Can they attack an application? And the answer to that is to use a technology called optimistic rollups, which some of you may or may not have heard of, which is effectively the direction that Ethereum 2.0 is heading towards now. So in an optimistic rollup type scenario, so if you want to implement your application as an optimistic rollup, your application basically becomes a sidechain or a Cosmos zone, and you effectively have that sidechain or Cosmos zone, or it can even be a standalone blockchain effectively. And you basically post all the block data for that chain onto LazyLedger or some other data availability layer. And these block headers that you put, these blocks for your sidechain that you post, they have headers that contain what's called a commitment to the states of the chain. And the short story is that if any application, if any sidechain blocks contain invalid state, then this can easily be detected, and the fraud proof of a proof of that could be generated to allow everyone to reject that block that is following that specific Cosmos zone or sidechain. And this is only possible if the sidechain blocks are actually posted onto a data availability layer like LazyLedger. Because if the blocks of that sidechain or zone are not posted to a data availability layer, then you basically effectively have to trust the validators of that zone, which you might not do because, as I mentioned, you have this fragmented security model where anyone can create a malicious zone. And if the zone is malicious, then the data behind that block might not have been published, and therefore you cannot prove or detect that certain blocks contain invalid state. At LazyLedger, we're also planning to start in January to work on adding optimistic rollup support to the Cosmos SDK, so that in the future people will be able to deploy chains using the Cosmos SDK but instead of using Tendermint consensus for that their chain, they can instead use implement their chain as an optimistic rollup that simply uses another chain like LazyLedger as a consensus and data layer. And that chain would effectively inherit the consensus and security of LazyLedger, so that every single zone that's using LazyLedger for consensus and data availability would have the same level of security. So in this kind of model, this is effectively a modular architecture for blockchains. Now, in the standard architecture for blockchains, which is what I would call a monolithic architecture, Ethereum, for example, the consensus and execution layer and the data layer are all coupled together. For example, in Ethereum, the Ethereum virtual machine is part of the consensus protocol or consensus rules of Ethereum. And so effectively, all the consensus nodes have to validate every single transaction, every single smart contract. But what we're doing, what we're trying to do with LazyLedger is by having a minimal consensus and data layer, all the execution happens on layer 2. So effectively, that's decoupling the consensus and execution layer. And so that basically makes it possible for anyone to deploy their own execution layer on top of LazyLedger. And that execution layer would, for example, be a Cosmos zone that runs on an optimistic rollup using LazyLedger as a consensus layer. And we can draw some parallels with this if we look at the history of the web. So when the web first came about in the 90s, pretty much like every website was running on its own dedicated server. So if you wanted to operate a website, you would effectively have this. You would effectively like run it on your own computer or have a server somewhere, and you would run a HTTP server and serve a website. And then a few years later, this idea of shared hosting came about, where people started like renting out their server space and gave people FTP access, and you allow people to upload HTML files or PHP code to the server, so that many different websites can run on the same server. And that's what services like GeoCities and Bluehost effectively achieved. And then in the 2000s, when the idea of virtual servers became possible, and the cloud effectively gained prominence, services like Amazon Web Services started to get popular, and that effectively allowed everyone to create their own virtual server with its own execution environment. Because with the shared hosting model, where every website is hosted on the same server, that's very limiting because you're limited to the execution environment that's running on that server. In terms of it might be running, for example, a PHP 5 or something like that, or some old version of Python, and the only way you could update that is if you had your own server. And that's effectively what virtual servers allowed people to do. It allowed people to have their own server with its own execution environment, um, but all of those virtual servers use the same physical server. So it kind of became the best of both worlds because it gave everyone the flexibility to install any software they want on their server, but without the overhead of having to kind of actually have a physical server. And I think I see a lot of parallels with this with the decentralized application ecosystem. So when Bitcoin came about in 2008, um, the idea was, Bitcoin was one chain that did one application. And Tendermint also follows a similar paradigm where anyone can create their own chain for their application. And that's a lot of overhead because, as I mentioned, it's not easy work to create a decentralized and secure consensus network from scratch with hundreds of validators that's sufficiently decentralized. And then in 2014, Ethereum came about and made this idea of the world computer popular, where effectively every application runs on the same computer. And the problem with that model is that it's very unflexible because you're limited to Ethereum virtual machine, and it has very high gas costs if you're trying to do something that the Ethereum virtual machine does not inherently support. And in many cases, it doesn't make sense for users of your application to also have to take interest in the execution of every single other application running on that world computer. And what we're trying to do at LazyLedger is kind of really bring the best of both worlds, which is to allow people to effectively have their own chain with their own execution environment, but without the overhead of having to actually deploy your own consensus protocol, because you can simply implement your chain as a rollup on top of LazyLedger. And so the idea is that for the first time in history, we want people to be able to very quickly, within minutes or a few command line a few command line applications, could very quickly deploy a completely decentralized and secure blockchain with its own execution environment in minutes instead of months. Whereas previously, if you wanted to do it in minutes, you would basically have to have a very small validator set or have to spend a long time to actually try to create a secure validator set by doing something like a token sale or or do some kind of token distribution event where you make sure your tokens are distributed to a secure set or decentralized set of validators. So if we consider the blockchain to consist of 3 layers, which is the data layer, the consensus layer, and the execution layer, we can imagine, Ethereum, which is the world computer model, to have proof of work as its consensus layer, and the Ethereum virtual machine as its execution layer, and all the applications are running on this same execution layer. And then with Cosmos, you can effectively think of every zone as having its own layer. So every zone has its own consensus layer and execution layer that runs in parallel with every other consensus layer and execution layer. And all of those zones communicate with each other using IBC, or the inter-blockchain communication protocol. Now with LazyLedger, we kind of really want to, as I mentioned, bring the best of both worlds, which is LazyLedger provides a very minimal consensus layer that can be plugged into the Cosmos zones or the Cosmos SDK as a rollup. And you can effectively define your own execution layer on top of LazyLedger, which can be using the Cosmos SDK, for example. And so that effectively allows you to create your own sovereign blockchains while using an existing known to be secure consensus layer for that blockchain. So if you compare Cosmos with other projects, so if you look at Ethereum 2.0, for example, the Ethereum 2.0 has a beacon chain that manages all the shards, and all of the shards are considered to have a uniform level of security, so that they're all equally secure. And then you have Polkadot, for example, which has this relay chain, which also kind of takes an interest in the availability of all its parachains. And then if you consider Cosmos, Cosmos zones, at the moment there isn't really a parallel to that. The Cosmos hub is not a parallel to the beacon chain or relay chain, because the Cosmos hub does not really kind of take an interest in the validity or the security of other zones. At the moment, effectively, if you want to make sure that the Cosmos hub only approves zones that are sufficiently secure, you effectively have to rely on some kind of like social governance mechanism to make sure that all the chains added to the hub have some minimum level of security and can be trusted. Because without some kind of shared security layer, then the Cosmos zones can't easily kind of trust each other without going back to the social layer. So LazyLedger tries to kind of fix this by providing a shared security layer that Cosmos zones can opt into. So, and I think the nice thing about this is with Ethereum 2.0 and Polkadot, the beacon chain and the relay chain are inherently enshrined to those protocols in the sense that they're not optional. Like you have no, if you have, like for example, in Ethereum 2.0 shards, they obviously have to use the beacon chain, or with the Polkadot parachain, well, I guess you can create an independent parachain to some extent, but if you want to operate with the main network, you basically have no choice but to use the relay chain. So in some way, it's enshrined and hard coded into the kind of design of or architecture of the protocol. But I think with Cosmos and LazyLedger, I think the nice thing about it is that they're both opt-in to each other. So none of them are enshrined to each other. So LazyLedger isn't enshrined to Cosmos. Cosmos zones can opt in to using LazyLedger as a consensus layer to get more security and to have a shared security layer. And I think this is more in line with the kind of idea that blockchain should be more modular, or the more kind of internet of blockchains philosophy that Cosmos zones, that the Cosmos ecosystem tries to affect. So if this sounds exciting to you and you kind of want to participate and follow the development, you can join our Telegram chat at LazyLedger Chat, or follow our Twitter and check out our website. I think we have 3 minutes for questions. If anyone has questions, I'm not sure if I can see how I can stop sharing my video. Okay, I think we have one question. Can you speak? So Gregory for Region Network asks, can you speak directly to the complementariness between LazyLedger's approach and evolving the role of the hub in the ecosystem? Yeah, sure. Well, I think Zaki has actually a lot of ideas on that, and I think I mean, my kind of vision is that I think like there can still be some role of the hub having some kind of like social governance system to allow certain zones to connect to the hub. However, so I think there's two. I think in the future there can be two approaches to adding zones to the hub. There will be a low barrier approach and a high barrier approach. I think for the low barrier approach would be to simply create a Cosmos zone that posts all of its blocks onto LazyLedger as a rollup, And effectively, it would be very easy for the hub to trust that zone. Because if the hub trusts LazyLedger, then it can pretty much trust almost any Cosmos zone that is using LazyLedger as a data layer, because the hub will know for sure that effectively that zone cannot easily misbehave. So in terms of the relationship between LazyLedger and the hub, I see LazyLedger as reducing the barrier to adding new zones to communicate with the hub, provided that in the future the hub will trust LazyLedger as a consensus layer. However, I think there can still be certain zones that are considered to have a sufficiently secure validator set that do not need to use LazyLedger and can still go through the governance process that the hub has to connect to the hub directly without using LazyLedger as a data layer, if that makes sense. Does that answer your question?
Cool. So we are at time. Thanks so much for the really great presentation.
Thank you.
All right, we're going to transition to the next talk now.